Squared plus bx plus c. So we would take the 4 to the other side. So eliminate c by adding it to the other side. And I left a little space here. Peter, why did I leave a little space there? What does step 2 say to do? Right, so we are going to find a value that is a perfect square, and we're going to add it to both sides of the equation, which is why I left a little space. So Peter, what is b? And when you divide it by 2 and square it, you get 9. 9 is a perfect square. 3 times 3 makes 9. That is the goal, to have a value that is a perfect square. So we would add the 9 to both sides of the equation. Part 3 says factor the left side as a perfect square. So x squared minus 6x plus 9. How does that factor? X squared minus 6x plus 9. Darby? Yeah, x minus 3 squared. Because negative 3 times negative 3 multiplies to be 9, but adds to be negative 6. So really this is x minus 3 times x minus 3, but it's a perfect square. So it's a quantity square. And then on the other side is 13. So this form right here would be my graphing form. I would take the 13 to the other side, and then I would have H and K so we could graph the vertex, which was all the way back in chapter 2. That was October. That was a long time ago. We are going to proceed to solve, and yes, we will be solving this as well to find intercepts. So you complete the square to take it into a specific form, but also to find the intercepts of the graph as well. So it's 2 reasons to complete the square. Parker, how would you finish solving x minus 3 quantity squared equals 13? Yeah, square root both sides. And then you end up with x minus 3 equals, what goes in front of the 13 once you take the square root, Parker? All right, every single time. And then get x by itself by taking the 3 to the other side. We are going to leave our answers exact. Very rarely will we get decimals. Even if we're graphing this, we'll graph it as an exact and we'll do a little bit of mental estimation. So solving using completing the square. Questions? All right, so let's try another one. We have x squared plus 2x minus 8 equals 0. So the first step is to take c to the other side. That's always going to be the first step. Negative 8 isn't a perfect square. So we eliminate it, take it to the other side. And I like to leave myself a little bit of space. You don't have to. So Brenna, what number did you add to both sides of the equation? Yeah, so you're dealing with 2, you divide it in half, and then you square it, and that's just a 1. So Brenna, when you factor the left side, you get, and the right side is 9. Yeah, so this one works out pretty nice. If it works out nicely like this, then you should have exact values because you can take the square root of 9. So x plus 1 is plus or minus 3. So Cole, your 2 solutions. So a positive 2 and a negative 4. If you get exact solutions like that, what does that tell you about the original equation? Here, it was factorable. Yeah, we could have factored it, but we wanted to practice completing the square, and it does work whether you factor it or complete the square or use the quadratic formula. And now you know that they all give you the same answer. There's just different ways, and it depends on how you approach solving it. Questions with those two problems? All right, so we know that it's not always going to be that straightforward. The next two problems have a coefficient in front of the x squared. When you complete the square, your coefficient must be 1 in front of x squared. So it must be a 1. It cannot be anything else besides the number 1. So in the example on the next page, or the next slide, we have 2x squared minus 6x equals 11. Now, the first step is to still eliminate c. So if this problem initially said 2x squared minus 6x minus 11 equals 0, if that were my beginning problem, you would still take the c to the other side. So that's always the first step. You eliminate c. It has nothing to do with completing the square, so you always move that to the other side. In this case, it's already done for us. What do you think you'd have to do next? Right. Yeah, we're going to divide by 2, but we're going to keep that 2 in the problem, and we're just going to factor it out. So we're going to pull it out, just the 2, not the variable, because remember, our goal is to factor or complete the square, and in order to do that, your variable still has to be squared. So we're just pulling out the coefficient in front of x squared, whatever it happens to be. So we would have x squared minus 3x, and I'm going to leave a little space. And then on the other side is 11. The reason I don't want you to divide that 2 out is because that 2 tells us graphically how wide a graph is or how narrow a graph is. And if I completely divide it out, then I've changed the shape of the graph, the steepness of the graph. So we factor it out and keep it in the problem. All right, so we pulled it out. The next step is to take b over 2 and square it. B is now -3. So once you pull out the coefficient, you're no longer using that initial equation. So we're looking at taking -3 divided by 2 and squaring that number. Do not give me a decimal. How can you square -3 halves, Peter? 9/4. So you square the top, you square the bottom, and that value is 9/4. Now, on the other side of the equation, remember we have to keep this equivalent. There is a 2 in front of the parentheses that we factored out. We didn't divide by the 2, we kept it in the problem and factored it out. That 2 is being multiplied by 9/4. So when you go to add the number on the other side, you're not adding 9/4. What are you actually adding, Jenny, to the other side? 9/2. So make sure that it's still equivalent. So yes, you added 9/4, but that 9/4 is really being multiplied by 2 because it's inside the parentheses. So 2 times 9/4 is 9/2. We're going to factor this as a quantity squared. And there is a little trick. Jenny, do you remember the little trick?
First term and the last term, and it's the sign in the middle of the first equation that we put in the factor.
Excellent. Yeah. So you're taking the square root of the first term, which is just x, the sign in the middle, and then you're taking the square root of the last term, which is 3/2. Nice. So I have x minus 3/2 squared, because if I FOIL this out, I'd go back to x squared, and -3/2 and a -3/2 is a -3. And then again, 3/2 times 3/2 makes 9/4. On the other side, we have those fractions that we have to add together. Our denominator is a 2, And if I multiply 11 by 2, that makes 22 11ths. So now I have 31 halves. So if I were to graph this, which we will be doing the rest of this week, the reason I don't want you to divide at the beginning is because our equation that we will be looking at will be something similar to this. It's not going to be exactly like this because we're doing circles tomorrow. But that 2 in front of the parentheses tells the graph to stretch vertically. So if I totally divided it out, then I wouldn't have that stretch in the graph. So that's why we don't want to completely divide it out. Questions on that? So the directions here do want us to solve. So depending on what the question is asking us, I'll kind of just box this off to the side here. So because we want to solve and get x by itself, now we're going to divide by 2. Or instead of dividing by 2, there's a fraction on the other side. So I like saying instead of dividing by 2, let's multiply by a half since there's already a fraction on the other side. So this gives us x minus 3 halves and 31 fourths. So, what do you do to solve this for x?
You square root both sides.
Excellent. So she even simplified it, 31 over 2. It does work out nicely. You got the square root of 4. Again, take the square root of the top and the square root of the bottom. The square root of 4 does simplify. So your final answer is 3 halves plus or minus, and then the square root of 31 over 2. And we would leave it separate like this. Here is my rational, irrational. They really don't like being combined together in the same fraction, so we really do just leave it separate. Numbers have a standard form, just like equations have a standard form. So numbers get written in a certain way, equations get written in a certain way. So there's one final problem at the bottom. Of course, it's like this one. It's not going to be quite as nice and cheery for you to work on. It can't all work out exactly perfectly for us. So this final example, again, the directions say to solve. So anytime you're solving, you're finding x-intercepts, which we will be finding once we start graphing and looking at these actual equations. What do you do first to solve? So what's the first step, Peter? Right, no matter what, even though you're like, yeah, but I could just divide everything by 2. Yes, I know you could divide everything by 2, but again, if you're doing that, you're changing the shape of the graph. Yes, the directions say to solve, but I don't want you to get in the habit of doing it now when you won't be able to do it the rest of the chapter. So take C to the other side first, eliminate C. So get that -6 out of the way. It has nothing to do with the completing the square process. Then take out the coefficient of x squared, and that would be the 2. So x squared minus 5x is equal to -6. We pulled out the 2. So Cole, when you square b, yeah. 25 fourths, but on the other side, Cole, you're adding 25 halves. Nice job. So when you go to factor it, the square root of the first term is x. It's a minus again. That's the middle sign. The square root of the last term is 5 halves. So square root of the first and last term, the middle sign is the middle sign. And then we have to place a 2, which makes the 6 a 12. And Cole, when you add -12 and 25 together, you get Yeah, positive 13 halves. Don't forget your little squared with this game. So if I were graphing, I would stop here. We're not graphing today. We're solving. So continuing to solve, multiply both sides by a half. So now we have 13/4, and then take the square root of both sides. So Darby, your solution is? Are there questions on completing the square? You remember completing the square in October? Yeah. So tomorrow we are going to be working on the circle. And I just want to pull up the equation so you can kind of see. Oh, such a delay in here. Come on, there we go. So tomorrow's equation, you can see that like we have an x squared and a y squared and an x and a y and a number. So I wanted us to make sure we could complete the square and get a review in before trying to look at a problem and complete this square with two different variables squared, two different non-variables squared. So little review. The worksheet is in the packet, but I actually tweaked it a little bit this morning. So if you could go to Google Classroom and pull up that worksheet, open it up right now. Oops, not that one. No, I did the wrong one. Okay, don't do the one that I just opened. I'll have to redo that one. Try again. Here it is. Okay, make sure it says completing the square, not the one that I opened for Tuesday. So Monday, completing the square worksheet. And when you open it, there are 8 problems. I also have an answer key posted for the solutions. Please use completing the square to solve. So even though the first one is factorable, again, the goal is to get it into this perfect square form. Because that's really when we work on the whole next chapter that we work on, everything is going to be a quantity squared. And that squared quantity will tell us specific information about the graph. So you have 15 minutes, 8 problems. Really nice, Mrs. Kane. Hopefully you'll get most of them done. And then tomorrow we're starting the wonderful world of conics. And we'll look at the circle tomorrow.